All right. So, you've seen this before, this horrible mess of things. I went ahead and went in and I scaled my design because I knew that I wanted it to be a little smaller than this, 3D printed prototype, right, that I made. So I made some adjustments to it. And I wanted to just kind of talk about how I went about making some adjustments to it so that I can work with it to be able to do thin cut sand. So you'll notice I've labeled some, I do this quite a bit where I'll label things because I'll come back to this file and not remember a blessed thing about it. So a lot of times I'll do like a text component where I'll say, okay, well this was for 3D printing, right? And so I had generated these files. If we look at it in the perspective view, we can see that these have curvature to them, right? And these are the things that I sent to the printer last week, okay? So if I were going to want to make these through Thin Cut Send, it's not as simple since they've got curvature to them. I've got to account for that curvature, right? So I need a way to essentially flatten them, okay, and not lose their dimensions in terms of when they're flattened, okay? So the way I went about doing that was that the first thing I did was, and I'm going to show you this, I'll show you the wrong way to do it first, okay? This is a 3D object that has thickness. Rhino has a command called smash. And it will basically smash, and you've got options for exploding it. Okay, I'm going to say no to that. You can put labels on it and you can keep properties. Okay, I'm going to say yes to that. And I can hit enter. Now what will happen is it'll create a flattened version of this object. It usually does it down here in there you can see it's got like this flat, it's kind of a mess, right? So there's all this, these are all the parts, right? And if you hit explode, it'll basically smash and flatten out that. Now this works sometimes really well with things, basic primitive forms, but when you get into more complex objects, smashing is difficult. You can also do it, and I'll do it one more time. If I do smash, and this is also, there's a term in Rhino called unrolled developed surface. That's another command. It's very similar to smash. And if you hit smash again, and we say natural direction, this one I'll say explode, okay? Now watch what it does there. Okay, so it gives me all these components. So if we were making this like a paper doll, supposedly we could cut all those out and piece that back together. That'd be a nightmare, okay? So that's not what you want to do here, okay? So what I did was I came in and I chose a surface that I would want to work with. So I'm going to work with the bottom surface of this and the bottom surface of this. This is going to be pretty straightforward. It's a flat sheet. There is no curvature to it. So the way I do this is I do extract. There's a command called extract SRF. Okay, it's right down here. So extract SRS. It's extract surface. So I just start typing it in. And it'll say select the surface that you want to extract. So if I'm wanting to get this surface, I just make sure that I get everything that's there and I hit enter. I can say copy yes. I'm saying copy yes, so make sure you do that. And I'm going to leave the output layer to the same layer. And I hit enter. And then what I can do is I can move this over. And now I have this surface. Now, I do want to show you, this is made up of it always kind of does separate surfaces. So immediately when I'm done with that command, I usually join those surfaces together, okay? So now I've got a joined single surface. Now the fork is going to be a little bit more complex, okay? So we're going to do extract SRF on this. And I'm going to zoom in, I'm going to click there, there, there. You can see it's broken up into a lot more okay? And then I hit enter. And then I immediately hit join, and it joins all those into one surface, okay? I'm going to show you a little thing here that you have to watch out for. Sometimes you'll have, I'm going to flip this around so you can see if I were doing the top surface, which I could extract this top surface if I wanted to. Okay, I click on this. Whoops, we got to do extract. Whoops, not help. I click on extract SRF. Now notice this, depending on what view you're in, you may have different surfaces that you don't realize. So earlier today I was doing this. I want to show you what happened. So I did this, and I went ahead and I just extracted the surface. But when I look closely, oh, look, there's a couple little ones. You have to really pay close attention, because if I tried to join those surfaces after I did this, it wouldn't let me, because there's actually a gap there because I didn't select all the surfaces, okay? So I hit enter, right? And then I should be able to bring these over and join those, okay? And we'll go ahead and hit join. So now we've got this, just a surface, okay? Now, I did go ahead and use the top surface of this when I did this earlier today instead of the bottom one. The reason I did that is I wanted my piece to be a little shorter. I'm gonna have to put this bevel, right? We can't do that from Sin Cut Sin, put that bevel in there. So I'm just gonna cut it short here, so that's what I wound up using. Now, if I take this and I say smash, I'm going to say explode no, and I hit enter, it will generate a surface that is clean and flat. Okay, so I basically took that thing that had curvature and flattened it. So I'm going to bring these over so you can kind of compare them. Whoops, wrong thing. And I know this is, some of you are like, whoa, this is kind of complex. You'll get the hang of it. And this is mainly for people who have curved things or things that have bends in them, people who have modeled stuff. To be able to get an accurate thing, we have to, flatten it. Okay? So if I were to now take those objects and I were to measure them, from the same location, are they going to be the same? No. Right? So this gives me, I got to make sure I choose the long one, right? When I go to export this to Sin Cut Sin, I'm going to generate my curves off of that object. Okay? Does that make sense? Okay, and I'll do that for each one of those forms, okay? And eventually, and this is what I have here, I have my smash surfaces, okay? And then eventually I take these and I say make 2D. I make sure that I turn off hidden lines. I'm going to turn off group output, and I say okay. And what it'll do is down here at my origin, it'll give me a clean set of curves, right? Now you'll notice that it does not, it explodes them, so you have to come back and join that. All right? So this is what I can send to Sin Cut Sin to know that this is accounting for the curvature of my design. Does that make sense to everybody? Okay? All right, and again, I recorded this, so hopefully we'll post this. You can come back and you can look through that again. So if you've got a design that's got curvature to it, you're going to have to create a flat template eventually. All right? Are there any questions about that? Nothing? Okay, all right. So the next step would be to get this ready. If we want to create a prototype here, I can get this ready for milling here. So I'm just going to hide all this and just keep this active, right? Now we know that our mill has a longer capacity in what axis? In the X, that's right. So what should we do here? Rotate, that's right. We should rotate it. And that'll assure us that we are cutting in this long direction we have, since we have less room in the Y. Now, a couple of things I could do is I could go ahead and I could start to nest these, right? If this is hanging out over here, it would just make sense that I would kind of, you know, move that over a bit. Now, we don't want to get too close because we have to run an end mill through here, right? Now, remember, this is the thing that Evelyn was talking about last class. If you're sending this to Send Cut Send, you have to decide. You might want to try uploading one piece at a time, or so that they can nest them more accurately, or you might say, well, I'll upload just my fork parts, but I'm going to nest them pretty tight. So with a laser, you know, you could have these pretty darn close, okay? So this is where, you know, just pay close attention to how you're setting these up. But for the sake of our milling, I'm going to undo that because I know that I need to fit an end mill through here twice. It's going to come around this object and it's going to come around this.
I would keep in mind with Send Cut Send that you probably will have to account for a little bit of the edges being filed off in terms of tabs and stuff, because my stuff is not always
Exact, right. It's got a curve.
little nubs and stuff on it.
Yeah.
It's not bad though.
Yeah.
Not crazy.
Compared to cutting out yourself.
Yeah.
Right.
Or like, it's not like calculating plastic cut. It's like,
Yeah.
stuff.
All right, so let's get this set up for milling. So let's do a little bit of a review here. What would be my first steps in milling this? Huh? Stock, yeah. Yes. So stock, yeah, we're gonna do stock first. So we'll do box stock. Okay. Now, it's telling us right now that our object is, I hit copy bounding box, it's telling us that it's 5.6, right, in the X, and it's 2.8. So we're just gonna leave that. But we know the stock that I'm gonna be using is 0.125. I'm gonna use 1/8 inch stock. All right, 0.125. So now I can hit OK to that. All right, what's my next step? Huh? Any- No. Align, that's right. Align. And there's two steps to that, right? The first one is aligning the geometry with the stock, yep. And we're going to put the geometry at the top of the stock in this case, and we'll leave it centered, okay? So we don't adjust anything, we just have to make sure we say okay to that. And what that did was it made sure it dropped our stock down beneath our 0 in our view. So our geometry, if we click on it, it's sitting on top of the stock, okay? So that's what that did. All right, what's our next step? Yeah, set world coordinate system, that's right. So set your world coordinate system, and we're gonna set this to the stock box, to the highest Z, and to center. And then we say okay, and it's gonna move everything, and we're gonna hit our little zoom extents button, and now we can see that the 0, 0 is at the center of our stock, it's at the top, our geometry is at the top, so everything's ready to go, okay?
What would happen if you did not align it to the top of the stock?
Well, if you, let's just do that, I'll show you. So if you had it right here, down in the bottom, and you told it to mill an 1/8 of an inch deep, okay? It's going to mill an 1/8 of an inch immediately from the top of the stock down. So you'll be milling into the table immediately and milling through an 1/8 inch instantly, even though you wrote the program for multiple steps below. Does that make sense? So that's what would happen. So I'll go back and align that. And then I'm gonna have to go back, and anytime you change something, you have to go through those 2 steps, okay, of alignment to make sure it's where it needs to be. That was a big hurdle for me when I first started learning CNC machining, because I didn't realize if I messed with something and I moved it around and then I didn't reset that, I would wind up milling into my table, or I would tear up a bit, or whatever. So all right, so our next step, this is going to be new stuff that we're going to be covering now, because last time we did a 2.5 axis operation called engraving, right? Well, this time we're going to be doing what's called profiling. We're going to profile the parts, okay? So to set that up, we're going to go to 2 axis, profile, and the pop-up window will come up just like it did for engraving, and it'll be basically asking us for a lot of the similar information that it did before for engraving. Now the first thing is to select your regions, okay? Now, if I select these regions, what am I wanting to profile first? What should I profile first? The holes, that's right. The interior regions, right, would be first. So it would be this, it would be this, and it would be this. So I cannot profile anything else other than those 3 things, because they are inside and we want to mill on the inside of the line, right? So I can't select my other geometry, because if I mill it on the inside of the line on it, it would be too small, right? So that's all we select there. Now we'll go to our next tab. We hit Tool, and we're going to change to an end mill. Now I'm going to write this for a 1/8 inch end mill. Now guess what width my slot is? It's 1/8 inch. So it's not going to let me do this, but I want to show you what happens when you do this, okay? Because they're exactly the same size, it won't want me to do this, but I'll go ahead and do it anyway. So we did set our tool, feeds and speeds. We're going to load from the file. We're cutting 6061 aluminum. We're using a carbide bit, and our speed is going to be 4500 for our spindle. Okay, we'll say okay, and it automatically changes these settings. Clearance pane, I don't need to set anything. Cut parameters, I do need to change something here. I need to tell RhinoCam that we're cutting on the inside of our geometry. Do you see this right here, this little click button? So that is going to know that, okay, I need to cut on the inside of that curve. That's all we need to change in that tab. Except for one other thing I'm going to come back to, okay? I'm going to wait on that though, because I don't want to confuse you right now. So I'm going to say minimum distance. That'll make sure that it doesn't jump all over the place, going from one geometry region to another. We don't change anything in cornering. And then we have advanced cut parameters, which I'm going to come back to as well. Entry and exit, I want to make sure I say along the path. And I'm going to go in at a 45-degree angle. So what this means is how it enters the cut, it's coming in at a 45-degree angle and starting to cut. Now we didn't have this before with our engraving. So why would we want to enter into a cut at a 45-degree angle? And I'm going to show you right now. So this is my bit. My options are to, if this is my stock, to go or to go.
It would be easier on the bit, wouldn't
It would be easier on the bit. Good job. Yes, it would be easier on the bit. If we simply plunge to a depth, it's putting a force on that bit immediately, okay? So that's really hard on the tip of your bit to plunge to a depth. But if we come in at a 45-degree angle, it eases into the cut, and it will compensate. It'll come back and hit. Once it's into the cut, it kind of comes back and then picks up what it missed, okay? But it just is a much easier entry. I think of it kind of like, it'd be like if you're driving on the interstate and they made the on-ramp a 90-degree instead of a merge curve, okay? Can you imagine what that would do to the flow of traffic, right? Okay, so that's how I think about that. Now, when we get out of the cut, we can come out of the cut, and there's ways of coming out of the cut where you would actually loop out of it, okay? So it's the same, it's similar, like you're getting off the off-ramp. It's supposed to be a smooth, you don't just stop and then crank out. But in this case, I am going to say none to this. Now, where this is problematic, if I say none, when it lifts out of the cut, sometimes it'll leave, if you're in the path of it cutting this thing out, it'll leave a little dimple along the wall, the face of the cut. And it's because as soon as the cutter lifts out, there's less load on it, so there's a little flex in the cutter and it leaves a little dent. So if it exits outside of the workpiece, it makes a smoother face to your thing. I'm not too concerned about it. It's pretty minor, so I'm going to say none to that. In the future, we may change that though, and I'm going to make sure I click Apply Entry Exit at every cut level, okay? Then we go to cut levels. Now, in this case, we can tell that our geometry is at top. That's default. We know we've got to cut through 0.125 inches of stock. I hit Tab. It gives me a rough depth and a finish depth. You can actually tell Rhino to cut a certain amount where it roughs it, and then it comes back and does a finishing depth for the rest of it. I usually don't mess with that. But this second set of rough and finish is very important. If I leave this one here, at 0.125, you know what it'll do? When it starts to cut, it'll come down and it'll plunge right straight through your stock to 0.125 and then cut it out in one pass. Now, do you think a little tiny end mill can take that? No, it needs to go in increments. So this second set of rough and finish is where you can set an increment level. This is where you're basically selecting the layers that you want to cut through. So with an 1/8 inch end mill, I'm going to be very conservative. I'm going to take off 0.02 at a time. All right? So this will basically take 0.125 and divide it into 0.02 increments until we cut through the material. Does that make sense to everybody? Okay. And you might say, well, how do you know that? Well, there's a thing called, for engineers and for machinists, called chip load. And chip load is the optimum amount of scoop of a chip that a cutter should take and remove, and it's all dependent upon the speed of the spindle, the speed of the cutter, the rate that you're moving into the material, the type of the material you're cutting, the number of flutes on the cutter, okay? There is software that will help you calculate the optimum chip load, okay? We don't have that software. I just base it off experience. So I know with a 1/4 inch end mill, 2 flute end mill in aluminum, I can take off anywhere between 0.04 and 0.08 depth of cut, okay? 0.08 if I'm being aggressive, 0.04 if I want to be able to run my machine a little faster in terms of how fast it's going around the material. I don't have to baby it. With a 1/8 inch end mill, I just know that 0.02, I could probably go 0.04 and push it a little bit, but I'm like, why do it? Now, some people will say, well, if you're cutting things for a living, you want to have the optimum chip load. You also don't want to be dulling your bits. So there's a lot of science behind this. I want you to know I'm teaching this from an art perspective, okay? So we're not going to get into all that, but if you were to go to machining school, they think this was crazy how I'm teaching you. They'd be like, oh my gosh, like teach them the right. But I don't know that you want to get into all that. I'm guessing. Right now, if you're like me, all you want to do is just cut your parts out, right? And not break a $20 bit, okay? So, and I'm not trying to make money at this either, right? So I just want you to know that. That's my little caveat, that if you go on from here and you get into this, don't come back and say, Frankie, you're an idiot. You taught us the wrong way, okay? All right, okay? So we've got everything set up. Now I'm going to hit generate. Okay, now it says, could not find valid data, okay? It goes ahead and writes the program, but it blows it apart. Now the issue is that if I were to measure the dimensions of this is exactly what my bit basically is once I round it up, right? So it's basically RhinoCam saying, hey, dude, you cannot run that 1/8 inch end mill around this perimeter. It just will not work, okay? So I have to go back, and some of you were asking about this one day, like, how do you go back and adjust this without having to rewrite another one? You just double click on this, and you can reopen it, and we can change our tool. And so we can say, oh, I've got a 1/16 inch flat end mill. Let's use that instead, and we'll hit generate. And you'll notice it creates a toolpath. And if we look at it in this view, oh look, it arranged automatically. It told us that to get to that depth, we've got to take 1, 2, 3, 4, 5, 6, 7 passes, depth of cut, right? With a 0.02 depth of cut to get through that stock, okay? Yeah.
Will it do one cut at a time, or would it be like a 3D printer where it goes around and like it does one layer and then does one layer and then one layer? Does that make sense?
This is what it'll do. So if I slow that down, right? So it does one section at a time. It'll do one section at a time. Now, you can change that. And guess what? And that's what's cool about this program. You can go back. I'm not showing you all this stuff, but if we said cut levels, we could say go level first. And level first would go to 1, then go to the next one, go to the next one, and then it would go back to the second depth on that one, and then that, but it wastes a lot of time. So you can change everything in this program, you know. Okay, so that worked out really well. Okay, so now, if I want to cut out the outside, if I know I'm cutting through the same thickness of material, you know what I can do? I can copy, and I can paste. Okay, so now that I've pasted this, all I need to do is remove that geometry, and then I can select new geometry, right, which would be all this. Now if I go ahead and generate that, oh, look what happened. It put my toolpath on the inside because we had written this for inside. So I have to make sure I go back to my cut parameters, and I need to say outside and then generate, okay? So if we were to watch this, we can turn off our toolpath. We can see that it cut clear through those pieces. All right, now, what's the problem with cutting clear through those pieces? Yeah, they're gonna fly out of there, and they're gonna get hit, they're gonna get nicked by the bit, they're gonna fling it out and smash your face, right? So we gotta figure out a way to kind of control that. We didn't have that problem on the first one. Now the other thing we can do is we could speed this up by using a slightly larger tool, right? We could, instead of using that little teeny tiny 1/16 inch end mill, we could go back to our other end mill. We just have to change out our end mill in between, right? So I'm going to do that, and then under advanced cut parameters, there's a thing called bridges or tabs. And I can say I want triangular tabs, and I can tell it how many bridges I want. I want 4 bridges per piece. I can set a bridge height, so if I'm cutting 0.125, I might not want it to be 0.1. What do you think would be good to hold it intact? 0.05? 0.05? So let's do 0.05. And it's going to be almost a 1/4 inch bridge length with 4 bridges, and we hit generate. Now what that'll do is if we turn on the toolpath, you'll notice it creates these little V's, right? These little bridges. So there's a little bridge there, little bridge there. So I'm always paying attention to like where it puts those. If it's going to be hard to cut or file off later, I try to, notice that, okay? But if we simulate this again, and we turn off our thing, you'll see those little bridges. See those? That's going to keep my pieces intact. Okay? All right. Now, a few other things to talk about. When we mill, there's a couple different ways that an object can be milled out. There's what's called climb milling. And I'm going to show you this. So there's that little picture up there. It shows the end mill, and the flutes are basically the rotation of the cutter is going one way, but the cutter is always, or the table is always driving the work into the piece where it's climbing along. Now this climb milling gives you a little bit better finish. You typically use climb milling with harder materials. It's going to give you a better finish. It doesn't want to dig in, okay? Because you notice that the flutes are like throwing the chip out the back side, okay? Excuse me. Thank you. So conventional, it's really scooping, and a lot of times you'll get a much rougher cut, okay? And then there's mix, where it does a combination of both. So what mix does in RhinoCam is it cuts one way going on one level, and then the next time it goes the opposite way. So it kind of leaves an irregular surface, but it is a little faster. But we're going to go with climb. So that's one thing I wanted to mention that I didn't mention earlier. So, and different materials work better. Like let's say we're cutting acrylic. We might actually go conventional with acrylic or wood if we're worried about chip out, or if we're worried about frictions. You might actually mess with that a little bit and change that depending on what material you're cutting. And again, there's a lot of science behind that I'm not going to get into. All right, so the only thing we have to remember to do is, because we used 16th inch bit for one operation and we wrote the other operation for an 1/8 inch, typically what I do is I post these separately. So if I were posting this, I would say post, and I'd make sure that I've got Tormach Path Pilot inch. And I like to create a system for myself. So I might create a folder, honestly, first, like on my desktop. And I would say, this is flatware. And I usually do like underscore. And let me start back at the beginning here. A lot of times I'll do 01 because it's my first operation. And then I'll say point. Whoops, I don't want to do point. I usually do 06 125 underscore flat underscore. I know this sounds kind of crazy to do this naming convention thing, but this will help you later on, okay? Because you're not going to remember what bit to use, okay? Flat, I need flat, don't I? Flat, whoops. So make sure that you're putting in the information that you're using, what bit you're using when you post, because otherwise you got to come back and open this file up, okay? So there would be that operation, and then we could take and click on the next one. Now I'm going to warn you real quick, if you happen to be on this, like this, and then you right click on the other, see how I'm right clicking on the other operation, it'll post this one again. You have to make sure it's the one that's highlighted, and I've done that before and messed up my file before. So this time we're going to say, let's see, a lot of times I'll just do this, and then I can go back and just change the things I need to. And then we know this is going to be a 125 flat and flatware. And we post, okay? So there's our code for those two things, okay? All right, now, there's a slight problem, and I don't know if you caught this or not. What's that?
The size of the bit of
It's right, exactly. So notice that it's not cutting. It'll only go as far as it can go. Okay? So that's a problem, right? So what do I need to do? Smaller bit, yeah, absolutely smaller bit. Now, if I use a smaller bit, I'm going to be taking smaller increments, depth of cut. I'm going to be running the machine slower, okay? So, taking the knowledge that I have, I'm going to cheat RhinoCam, all right? We're going to cheat it. So the way I'm going to do this, all right. Whoops. Did I open the wrong one? I think I did. Let's see if I can find the right one. I may not have this saved. Let's see if we do. Yeah, I do. Okay, so before class, I came in and I was like, okay, I don't want to do that operation where I'm cutting the slot. I don't want to do it with a 16th inch bit. Okay? So what I did was I drew a line from midpoint to midpoint, and then I measured that line, and I subtracted 1/8 inch, because I would be subtracting off a 16th inch off of one end and a 16th inch off the other end of that line. Okay? And I scaled that line 1/8 of an inch shorter. I'm confusing you, aren't I? Okay. So I did this, it'll make sense in a second. I did this because what I want to do, instead of writing it as a profile, I wrote it as an engraving operation. I knew engraving would cut right down the middle of the line. But if I engrave all the way down to here, I'm going to wind up with a radius that's outside of my shape. Now, are you with me? Mm-hmm. Good. So I took off, to account for that, I took off the diameter of the bit, which would be a 16th inch off here and a 16th inch off here. So it would stop here. So if I look at my simulation of this, notice and that's what we want, because I want to come back and be able to file that by hand instead of having that be too sloppy and be cut over. Everybody got that? Okay. So this is my way of like cheating RhinoCam, because it doesn't know. Now, if my end mill would travel down this path, I did the same thing here. I knew it wouldn't get into here to create the shape, so I'll have to hand file that. We won't have that problem with sin cut sin, right? It's going to use a laser, so we're not going to have this issue. But I wanted to make sure, so I wrote a program, an engraving program, that just cuts on a line that I generated down the middle of each time. So I'm totally using this in an improper way, but I'm getting the result I want. And this is where I think that this is the benefit of teaching CAM and machining in an art program. And later I'm going to show you how we can create texture and surface. I showed this in my class, I think last semester. We can create texture without having to actually model three-dimensional texture into the thing, because we know how to use RhinoCam. So this is a total cheat on the system of how it's meant to work. So I didn't even use this. I'm like, no way, I want to use the same bit. So I used an 1/8 inch bit, and then I went ahead and did the same thing here. And it doesn't matter that it doesn't cut all the way down through there, because it's already done it in that operation. That makes sense to everybody? Okay. So this is actually what I did. I clicked on this, I held down Control, and then I hit post, and now I've got a file that I can post using one bit. I don't have to change the tool bit out and re-zero it. It's much faster, okay, because I'm using a bigger bit. Okay, everybody got that? All right, I think that's it. Are there any questions about that process?
Did you record this one too?
I did record this as well, yeah. Yep, anything else? Yeah.
Where was the bridge tool again?
Yeah, so if we double click on our machining operation, it's under advanced cut parameters.
Okay.
And it says number of bridges, and you have to make sure instead of saying none, it'd be triangular, and then it will create those.
You had mentioned with the bridge, that you look to see where the placement of those are.
Yes.
Or you don't like the placement.
Then I add more,
Oh, you
right?
just
I add more, or I change the distance between the bridges. You can either click
Okay, so
either
just
one.
little.
Yeah, because sometimes you'll wind up with a bridge right in the corner of something. You're like, oh man, that's gonna be a pain to get out of there, to file out.
Yeah.
And you'll find this later on when we cut your wood pieces for furniture, our stool, you were going to have to put bridges in so those pieces don't fly out. And you'll also realize that different materials require thicker bridge. Like plywood needs a thicker bridge. It needs a much thicker bridge because it's made out of ply. It's weak. It's not as strong as the metal. So yeah, I'm trying to think about, where does that placement go so that it's easy to take a chisel. In terms of wood, we'll take a chisel and we'll chisel that. We'll smack it and it'll break that, and then we can lift our pieces out safely and securely. Anything else? Those are all good questions.
And you were talking about copying and pasting since
Yep.
you just copy and paste it.
Yeah.
And then select different.
Exactly. So let me just do one here. So if I just, if I copy this and I paste it, and then you just double click on it, and if you said, I'd like to remove all that geometry and just cut one part, and then you hit generate, that's all you got to do. And then, if you said, I want to, cut it in a different pattern or a different way, that's how you do it.
And that would be like where you would go in and change from outside to inside and everything.
Yeah. You go in and change inside and outside if you were doing that too. Yep. The only thing to remember is, see, we didn't put bridges. So that's why I didn't put bridges. I didn't put bridges on those inside tabs. I have had it though, where if you've got a large enough thing that you're taking out of the middle, where you do want to put bridges, because otherwise, when it gets done, even though that's a part that's going to be removed, I've had it where it's been cutting it out, and if you don't make sure that thing is secure, it'll hit the bit and ricochet off of it, and usually catches the bit and between the wall of the piece you want and the piece that you don't want, and it cracks your bit and breaks it. Okay, but sometimes I don't. Oh, this is horrible. I shouldn't tell you this one and record it. Sometimes I don't want to have to file those tabs off the inside. So what I'll do is, as I'm cutting on the machine, I'll stand there at the machine and I take a wrench and I put the wrench on the part that's getting ready to fly out, and I put a lot of pressure at an angle. I hold my wrench and I put pressure up here on the wrench, and it keeps that in place as it finishes the cut. Then it lifts out, goes to cut the outside, and then I can reach in the machine and pick that out, okay? That's not probably the wisest, but it makes it so I don't have to clean that inside and break that tab. I do it all the time. And I'm careful about it. I'm not being reckless. Now, if it's a tiny, obviously you don't have your fingers in there holding it. That'd be stupid, right? Yeah, that'd be, yeah. So anyway, yeah, there's lots of things. And that, as we go through the semester, I'm going to try to teach you some of these little tricks, and I'll point out when there's stuff that's shouldn't probably do kind of thing too, okay? All right? But there's also things where it's like, this is what's tough, I think, with art is that, one day Adam was talking about, he's like, yeah, I saw a student over there, and they had to drill like 500 holes, and they kept clamping the piece down between every hole. And I'm like, well, yeah, it's because that's how we taught everybody. And he's like, oh, yeah, you're right. But he's like, you and I wouldn't do that. And I'm like, darn right I wouldn't do it. I wouldn't have clamped that thing to begin with. But it's because after you get enough experience, and that's where I think it's really tricky for some of you. Some of you, you hold everything we say to be gospel. It's like, oh, I must obey this. Right, some don't, right, some don't. And that's the one, I worry about both ends of the spectrum. I want someone to start thinking for themselves and say, that might not be a good idea. I might lose a finger if I do that. But I also don't want people to be like, they told me this, therefore I will always do it. I want you to think for yourself. So that's why, as artists, I think we have to figure out where we can bend and break the rules sometimes too. So instead of just being so locked in.
More than one occasion told a student, don't do what I say, not what I do.
Exactly. Yes. Yes.
Because I put my hands on the inside cuts over.
Yeah. Totally.
Let me do that for you. I don't know if it's
That is what I do, because